looking to write some six-digit integers down that must include 3, 4, and 5 and must have their digits in increasing order such that it's divisible by 6. So what does that mean if it's divisible by 6? It means the last digit has to be even and the digits, that makes it divisible by 2, and the digit sum must be a multiple of 3. Okay, so I'm going to systematically work through these, and I'm going to say it has to be strictly increasing. It can't be like 1, 2, 3, 3, 4, 5, or something like that. Okay, it has, like, the example kind of indicates that, and so that's what I'm going to go with. I think that's what the question intends. Right, so let's have a look. So because it must end in an even number, then we can't put, it can't end in a 5. So we could put the 3, 4, or 5 here. And that means that either this has to be 6 or it has to be 8. Now, if it's 6, the only possibility is going to be 1, 2. And if it's 8, it's also going to be 1, 2. So these are so put 3, 4, 5 here. I'm just sort of explaining. Must end in 6 or 8. Must start with 1, 2. Right, so I've constructed it to make sure it's even. Now let's just check the digit sum. So I'm going to get 6, 10, 21 for this one. This one's going to work. But actually, because this is 2 more, this one's not going to work. So I'll just write a little 21 and 23. Okay, on to the next one. We can just work our way through it like this. So next, 1, 2, 3, 4, 5, 6. We can put the 3, 4, 5 here. Now this time we can't put a 6 in. That's not going to be possible because we can't put anything here. So it's got to end in an 8. And it's probably best at this point just to write down all the possibilities. So it could be 1 and 6 here. Or it could be 1 and 7. Or it could be 2 and 6. Or 2 and 7. So just enough explanation put. Yeah. And then let's do the digit sum again. So here we've got 14, 19, 23, 26, 27. This one's going to be all right. And clearly when I add 1 to it, that's not going to be all right. I'm going to get 28. 27 is a multiple of 3, 28 is not. Here I've got 10, 21, 28 as well. And then, oh, sorry, I've written down the same one twice. That's meant to be a 7. I might have spotted that. Apologies. So in this one's just going to be one more. It's going to be 29. Now, to be fair, you could, and I think when I did it originally, well, not I think, I did, when I did this originally, I wrote down like A, 3, 4, 5, B, 8, and then kind of figured out what A plus B had to equal. So we've got 12, we've got 20. So A plus B plus 20 has to be a multiple of 3. So then I thought about it equaling at different values. So because B has to be greater than 6 and 7, then it's got to be like 27 onwards. So we can see that A plus B is going to have to equal 7 or 10. Um, and the only one that's going to work, because A has to be less than 3. And then, so the biggest that this could be would be if A was 2 and B was 7. That's not actually enough. So the only way we can get 7 is when we use 1 and 6, which is what I did here. So that's an alternative route. Quite like just writing down the arrangements though and then ruling them out. It seems a little bit safer. So far I've got two possibilities. And finally, last one. So this time we put 3, 4, 5 here. Again, it's got to end in an 8. Can't end in a 6. Right, and then actually all that leaves as our only possibility is 6 and 7. So digit sum, I've got 10, I've got 18, I've got 20. Actually, you can already see it's going to be multiple 3 because it's going to be 18 plus 15, which is 33. So there are three possibilities. I've written them all out. I'm not going to write them again. Nice question. Different. I've talked about a little bit about different approaches. In this case, I've just written down that I've just like shifted 3, 4, 5 along and written down the possibilities. Quite safe. Like I've talked about the fact that you could use this idea. That's actually what I did when I did it originally. I just kind of prefer this second method now, but feel free to use that one instead. Worked systematically through it, so we know those are the only options, and I've made my arguments throughout. So looks good.